morning class. Let us start with our next topic from data handling, which is the last topic, and the name of the topic is probability. Probability. Let me ask you one thing, that if I say there are chances that it will rain today, or most probably it will rain today. Third one, the chances are high that the prices of petrol will go up. So I think you would have observed three words: chances, most probable, or there are events occurrence. Again I repeat, you would have heard the word chances if I talk about, and most probable or probably, most probably or most probably. What are this? Do you think, are you sure if you are saying most probably it will rain today? Do you think you are 100% sure that it will rain today? The chances are high that the prices of petrol will go up. Are you sure the prices will go up? No. These two words show uncertainty. What they show? Uncertainty. What do you mean by uncertainty? Uncertainty means not sure. Uncertainty means not sure. If you are not sure about anything, you are uncertain about that particular thing. Are we clear? Are we clear about this? Sure? Okay. Now let's study about the probability. Probability is something like that only. It is a numerical means number, numerical measurement means we measure of chances of happening of an event. Like if any event has to happen in the future or will happen in the future, what are the chances? What are the numerical measurement for this thing? Are we clear? So it is a numerical measurement of the chances of happening of an event. Event always happen, okay, or occur. Do remember these two words will be prominently used in this chapter: happening or occurrence of an event. Clear? Now let's see what is an event according to us. First of all, we should know what is experiment. I am not talking about the science experiment we do. Let's see what is experiment. An operation which can produce well-defined outcomes. An operation which can produce well-defined outcomes. For example, if I talk about anything, let me take this coin. I am having a 1 rupee coin with me. I am having a 1 rupee coin with me. If I toss a coin, the chances are there either will be getting head or tail. Head or tail. Again I am repeating, if I toss a coin, the chances are there either I will be getting head or tail. What is head and tail in that? The head and tail in that is your outcomes, and if I toss a coin, that is your experiment, an operation which can produce well-defined outcomes. Yes or no? Very well defined. It's an operation, it's an experiment for me because it produces well-defined outcomes. What are those outcomes in terms of tossing a coin? Head or tail. Any doubt anyone is having with the definition of experiment? Clear? Now each outcome is an event. Each outcome is an event. If you get head on tossing a coin, that is an event. If you get tail, that is again an event. If you get head, that is again an event for you. Clear? Anyone is having doubt with event or experiment? Clear? So it is a numerical measurement of chances of happening of an event. Example again, most probably it will rain today. Clear with this? Most probably the chances of Indian cricket team to win the World Cup is very high. Yeah, or Asia's World Cup is very high. So I'm not sure, but I'm guessing the chances are very high. Clear? If you are not sure, the probability is 0. If you are not sure, for example, the event cannot happen. If I toss the coin, the two outcomes are either head or tail. Can we get any other outcome? No ways. So if I say on tossing a coin I get ears, do you think something is happening? Is there any probability? No, because there is nothing called ears as the outcome when we tossing the coin. Clear with this? So head or tail is the outcome. Now let's see the formula of probability of an event. Probability of an event. Again, event. Each outcome is an event. Let's see. A number of ways the event can happen upon total number of possible outcomes. Understand, it's very important. Number of ways the event can happen. Your event can happen in any way. Yeah. For example, if I toss the coin, on tossing the coin, I toss the coin, I throw the coin, I flip the coin. The number of ways the event can happen, but event is either I'll be getting tail or head, that is for sure. So can I say the number of ways the event can happen upon total number of possible outcomes? Now what are the chances of head to come as the outcome? What is the answer? Head can come only one time if I toss the coin, or head and tail can come together. Never. Head and tail will not come together in any situation if we are using only one coin. If we are using only one coin, either we'll be getting head or tail. So if I talk about the probability of getting head, the probability of getting head, can you observe something what I have written? Probability. P stands for probability and H stands for head. How to represent this? This is represented P in the bracket you write E, where P stands for probability and E stands for event. Probability of an event. Probability of getting head. Clear? Clear? Now how many times head can come if I toss the coin once? One time. Out of what are the total number of possible outcomes? Head and tail. Total are 2. Either we can get head or tail, that depends. But what are total? Total are 2. But out of 2 at that particular time, we'll be getting only 1. That is why the number of ways that event can happen, the event of happening of head at one particular time is 1 out of 2. So what is the probability? Probability is 1 by 2 of getting head. Similarly, probability of getting tail would be 1 by 2 because we'll be getting tail one time only out of 2. Any doubt with this? This is the formula. Very important formula. The number of ways that event can happen and total number of possible outcomes. Let's move on to the next random experiment. Random experiment, basically whose outcomes you know, but you can't make any possible depiction about them. Like you will know how many times it will occur. In tossing of coin we know head will come one time, tail will come one time. But if I toss the coin, are you 100% sure that now the head will come only or tail will come only? No, you are not sure. But you know either head or tail will come. But who will come first? That is not possible. You are not aware of that. That is not the possibility. That becomes random experiment. Clear with this? Any doubt? So rolling of a dice, outcomes are 1, 2, 3, 4, 5, 6. Because dice, I am taking a very small dice in front of you. Dice is having 6 faces. Let's see. 1, 2, 3, 4, 5, and basically where is 6? Let me search. 6. So how many faces? 6. 1, 2, 3, 4, 5 and 6. So what are the possible outcomes in case of rolling a dice is 6. Clear with this? This is a dice having 6 faces. Again I am showing you. I am having a small dice. 1, 2, 6 faces you can check. It is having 6 faces. So possible outcomes are 6 in case of a dice. Clear with this? We call it dice or we call it as a die also. Don't get confused with that. Both are same. Dice or a die is one and the same thing. Clear with this? So if I ask you, what is the probability of getting 1 on rolling a dice? What is the answer? How many times we can get 1 on rolling a dice? If I roll the dice 1 time, I'll be getting 1 only 1 time. But out of how many? Out of 6. So what is the probability of getting 1 on rolling dice? That is 1 by 6. Any doubt? Probability of getting 1 is 1 by 6 because we'll be getting 1 on rolling dice 1 time only. But out of how many? Out of 6 because total are 6. Clear? Any doubt? Like I think you play games where you pull out the chits. Yeah? Are you sure about which chit you'll be getting? Are you sure what you'll be getting? At the truth and there when we play, we pick up so many chits and then we decide what person will going to do what. Dumb sure us. Yeah? The same thing happens in that also. But are we sure that whatever I'm picking, whatever I was thinking in my mind that this is what I'm going to enact with, I'll be getting that chit only. No ways. Again, that is the probability. The choosing a chit from a tableau or anything, again is the random experiment. Clear with this? Any doubt anyone having? Sure? Next, shuffling of playing cards. I think you would have seen playing cards at your home. I will show you that I am also having right now playing cards to show you. Playing cards to show you. Everyone, I am showing you the playing card. This is what the playing cards are. Right? So, total number of playing cards. There are 52 playing cards. How many? 52 playing cards. It is called a pack of playing cards or a deck of playing cards. Two words are used. A pack of playing cards or a deck. D-E-C-K. D-E-C-K. A deck of playing cards. Clear? Now this 52 cards are separated into 4 groups. This 52 playing cards are separated into 4 groups. I'll show you which are those 4 groups. Namely, heart, diamond, spade, club. Heart, diamond, spade, club. Heart, diamond, spade, club. Again, heart, diamond, spade, club. Any doubt anyone is having? So these are the 4 categories in which we divide. Can you see heart and diamond are red in color, spade and club are black in color. This is what? Red in color, black in color. Now we will see how they are segregated. They are segregated in the form of, these 13 cards are segregated in the form of A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to this you have numbers. Then you have something called J, Q and K. J, Q and K. Clear? Let's see what is A. A is called Ace card. A. Ace card. What we call it as? Ace card. Why we call it as ace card? Because the value of this A card can be 1 or can be 21 depending upon the situation. If you need the lower number, you will be using it as 1. If you need the larger number, you will be using it as 21. Clear with this? Ace. 2, 3, 4, 5, 6, 7, 8, 9, 10. So you know, you would have seen. Now let's see the J, Q and K. J stands for Jack. The card of Jack. J stands for Jack. J-A-C-K. Jack. Q stands for Queen. Q stands for Queen. and K stands for king. Q stands for queen and K stands for king. And these three cards together are known as face cards. These three cards together are known as face cards because these three cards possesses face. Can you see the pictures are there? That is why they are known as face cards. What they are known as? They are known as face cards. Are we clear? Any doubt with this? Anyone? Anyone with a doubt in this particular thing? Shuffling of a playing cards. Clear with everyone? Okay. Let's take one particular example so that you can understand probability. Last example. Playing cards you will do in class 8th also. In class 9th and 10th you will definitely have questions from this. Okay. Understand? This chapter you are doing in this topic you are doing in class 7th and 8th in data handling. But in class 9th and 10th, this chapter will come completely separate chapter in class 9th and 10th, even in class 11th and 12th. Now let me take an example that if I say in a jar I am having, let me say that particular, I am having 3 purple marbles, 2 blue marbles, 3 green marbles, let me take my red marker also, and 1 red marble. Clear? How many means if I want to ask what is the total number of outcomes? What are the total number of outcomes? How many marbles are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is total number of outcomes? It's 9. But what are outcomes? Outcomes are green, red, purple and blue color. Any doubt? Now if I say what is the probability of getting red marble? What is the probability of getting red marble? Now what was the formula? Formula was the number of times the event happened upon total number of outcomes. Yeah? How many red marbles are there? 1. That is the possible outcome. And what are the total? 9. So what is the probability of getting red marble? Answer is 1 by 9. Any doubt anyone is having? Any doubt anyone is having in this? Clear? Now, last thing which I will tell you, that probability, the number, the numerical measurement always lies between these two things. Do remember, probability is always less than 1 but always greater than 0. It can be equal to 0 if the event will not happen. If I talk about what is the probability of getting black marble, can you see black marble in the jar? No, so black marble is not there. So what is the probability? Probability is 0 upon 9. 0 upon 9 is 0. So what is the probability? 9. So probability always lies between 0 and 1. This is called limit of probability. Limit of probability. This is an important question, very famous question, very important question. What is the limit of the probability? That probability always lies between 0 and 1. Here it means it is less than 0 and equal. It can be less than and equal. Sorry, it is greater or equal to 0, but it is less than or equal to 1. Are we clear? Any doubt anyone is having with this? By this, your data handling chapter is over. We'll start with the next chapter in the next class. Till then, take care. Bye bye.